I chose topic 4, phonation, anatomy and physiology, how we can change pitch, normal pitch for men and women, vocal tract structures, and how we manipulate them. Phonation is when the vocal folds are adducted or moved together and vibrate to produce an audible sound. Here I have some important structures of the vocal tract. Starting with respiration or breathing, I've got the diaphragm, the glottis or the space in between the vocal folds when it's open, the trachea that actually transfers the air in and out of the lungs, and then the lungs themselves. In the larynx, I'll go through each one of these, but I have the cricoid, the thyroid, the hyoid, the trachea, the vocal folds, the arytenoids, and the epiglottis. And then some other structures that are in the vocal tract and are important but less important for phonation and more important for resonance is the pharynx with the naso, the oro, and the laryngeo, the oral cavity that houses the tongue, the velum, the hard palate, and other articulators, and then also the nasal cavity. When talking about anatomy, it's important to understand the anatomical planes. We have a sagittal plane, a transverse plane, and a frontal plane or a coronal plane. And as you can see from the photos here, like it's clear what all of these planes mean. But then there's some other terms like anterior and posterior, which means anterior is closer to your visual field, where posterior is closer to your back. And then superior and inferior is closer to your head versus closer to your feet. So my head is superior to my shoulders, while my shoulders are inferior to my head. And then medial and lateral, which means closer to my center line. So my ribs are medial to my arms, where my arms are lateral to my ribs. And then distal and proximal means closer to my trunk. So my fingers are distal to my elbow, where my elbow is proximal to my fingers. The trachea, also known as the windpipe, is located at the cervical spine 6 bone to the thoracic 5 bone. It's made up of cartilaginous rings, and right above it is the cricoid cartilage, or right superior, and then right inferior is the carina, where the trachea splits into 2 branches leading into the lungs. And then right behind it is actually our esophagus, where we process food and liquid. And this functions as a place to transfer air in and out of the lungs for breathing and speech. The cricoid cartilage creates a full ring, and it sits right on top of the trachea and articulates with the arytenoids. The arytenoids sit right on top of it and create a saddle joint where the arytenoids can rotate and change the vocal folds in the way that they need to for speech and phonation. The thyroid cartilage actually houses the arytenoids and part of the cricoid in the vocal folds, and creates a flexible structure so that the speaker can change their voice when they want to. It also is open in the back, as you can see in the photo, and then in the front, it comes together and creates what we call the thyroid notch, which is prominent in men. The arytenoids are kind of triangle shaped, as we can see in the photo over here, and just above them or superior is the hyoid bone. Lateral to them, its housing structure is the thyroid. Right above them, as the apex, is the cornicolate cartilages, which are just really small, right at the top. And then just below it is the cricoid, and as we remember, those arytenoids sit on the cricoid and create a saddle joint so that the vocal folds can be modified. And then these are able to rotate to adduct or abduct the vocal folds for breathing and for phonation. The vocal folds, or the thyroarytenoids, are the main structure of phonation. This muscle is the one that vibrates to create the sound. This first photo is a posterior view, and this second photo is a superior view looking down. And we see that anteriorly they attach to the thyroid, and then posteriorly they attach to the arytenoid cartilages, and they're all housed inside of the thyroid. Pitch is a hearer's perception of the fundamental frequency, which is how many waves reach our ear in 1/100th of a second. So this is really about the hearer's interpretation. But as we lengthen the vocal folds, the pitch gets higher, which happens through the cricothyroid muscle. Or when we shorten the vocal folds, we lower the pitch, which is the thyroid themselves or the vocal folds. Women typically sit at about 215 hertz, which is what pitch is measured in, and men sit at 115 hertz. So women typically have a higher pitch compared to men who have a lower pitch. Also, stressed syllables tend to have higher pitch as well. The cricothyroid muscle attaches to the cricoid cartilage and the thyroid cartilage anteriorly. So since this is a posterior photo, we see this outline as a little wonky just because it's attaching anteriorly. But this muscle increases pitch by lengthening the vocal folds, and it brings the thyroid cartilage down towards the cricoid cartilage. And by increasing that space is how it lengthens the vocal folds. The epiglottis is a leaf-like structure. It's located behind the root of the tongue. It's connected to the hyoid bone via a ligament, and anteriorly it's convex and posteriorly it's concave. It functions as a seal during swallowing, which protects the trachea from any foods or liquid going into the lungs, and also protects the vocal folds in that manner as well. The hyoid is the only bone not connected to another bone in the body. It's just superior to the thyroid cartilage, so the thyroid cartilage is inferior to it. It provides attachment for multiple muscles and also allows for a wider range of motion for the tongue and the structures of the pharynx and the larynx because it's so movable. Here are some of my questions that I have for you guys, and I'll post the answers to these questions with the discussion post. These are the sources I used for my video. The second source is an online resource that I encourage you to go to. It describes all the functions of these structures and will highlight them. All the photos that I pulled for the slides, they were all pulled from this website, so it gives you a clear image of what's going on in the structures here.